Hello, hello. I hope I'm being seen and heard. Salutare tuturor. Hello, everyone. Cześć for our Polish audience. I'm Dan Avram. I'm manager of Pentalog's team in Brașov, Romania. And I'm honored to be the host of this week's PentaBAR. I'm exceptionally replacing Mihai, our regular host. As you know, PentaBAR is a series of tech events that started more than 5 years ago in Brașov as an opportunity for knowledge sharing and engaging with the local communities. Then PentaBAR quickly spread to practically all our Pentalog offices in Romania, Moldova, Vietnam, Mexico. The pandemic during the last year created the opportunity to transform our offline events into a series of fully digital online meetups, addressing a larger community beyond our geographical boundaries and our postal codes. And I'm personally grateful that it also allowed us to engage more easily with interesting and fun people, community leaders and tech experts from a variety of technical domains, and our guest today makes no exception. Of course, we miss the social interaction that usually followed before and after the keynote presentation during our meetups. This is maybe where the bar part from PentaBAR was coming from. But I'm hopeful that soon enough we'll be able to mix online and offline events and get the best value from both of the formats. You'll find all our PentaBAR replays on our website, pentalog.com. I'm sure a link will be yes, I see the link on our chat. I'm just getting around our chat. Right, here it is. So we have a large video library with all our previous events. Today's topic is related to Java and more specifically to the latest versions of Java, Java 15, Java 16. Our guest is a popular Java consultant in the tech community of Poland, a Java evangelist, speaker at various tech events, Piotr Przybył. Piotr, welcome to our PentaBAR. Thank you for accepting our invitation as a speaker. You also wear a tagline as a software gardener, and you'll be sailing us today the calm waters of Java, right? So I'll let you introduce yourself, but first, please tell us, how is a gardener sailing? You know, I'm a big fan of metaphors.
Hello, everyone. Thank you for this warm invitation, Dan. However, I'm not so sure if I'm that popular. Nevertheless, yeah, I consider myself being a software gardener, which means a person who takes software more like a gardener. So this metaphor isn't mine. It comes from the book, The Pragmatic Programmer. I think if you haven't done it so far, you should definitely read this book. We've seen like a second edition last year, I believe. And this metaphor is about, you know, that software is actually alive, pretty much like a garden. So in our climate, we of course have seasons, we have bugs, we have weeds, we have new plants to seed or to plant. Sometimes we need to, you know, get rid of too many plants we have, and so on. Basically, just as the garden is alive, you can just, you know, visit your garden twice in spring and then come in like early autumn to collect the vegetables and fruit, right? You can't do that. You need to take care of it, daily care. And so is the software. It's alive, basically. And so the gardener cares about the garden. And when it comes to sailing Java, it's because, yeah, I've been given numerous talks on Java, especially the recent versions, the modern versions, I call them. And I, generally speaking, have like a three variants. So surfing Java is when we have like 30 minutes just to scratch the surface. Then we have sailing Java to see more of the beautiful views of the recent versions, and there are also deep dives. You can find them on YouTube if you're really interested, or my personal weblog. And then these are like 2 hours more or less per each version. So sadly, we don't have that much time. So this is all about sailing Java today. So we will have 1 hour more or less to talk about new and cool Java features. I hope you will find them cool as I do.
Thank you, Piotr. And for our audience, please feel free to ask your questions during the talk. We won't wait until the end to shoot some questions. So I will politely interrupt Piotr's presentation every now and then. I have gathered a lot of questions from our internal Java community already, so it's clear that this topic is triggering a lot of curiosity, and you know, there will always be newer versions of anything. So what makes it worth migrating to a new version of Java, just generally speaking?
If that's a question to me, I like to answer this question by reverting it. So think about the cost of not upgrading. And that might be actually so significant that you decide that it's cheaper to take the effort, the sooner the better, and then migrate because you also get the benefits from the latest versions. So sometimes, of course, we can't upgrade to newer versions because of the changes which we see in Java, especially since Java 9, which aren't backward compatible. I mean, like Sam is going to say and Friends, for example. Which made some frameworks like kind of stack to Java 8, but fear not, there's Project Panama. I mean, we see more and more JEPs from Project Panama, more changes for the time being as a preview features, but soon they will be, or eventually there will be production features. So then there will be no big deal, you know, with getting like an off-heap memory manipulation and so on in a proper way, which doesn't involve SANMIS unsafe.
These are good reasons, but you know, there's a lot of status quo in the mind of a lot of our business stakeholders, not tech decision makers. If it works, don't touch it. I'm sure you heard it.
Yeah, I think let me use a metaphor, since you like metaphors. Let me use metaphors from the car industry, right? So I believe all these people are driving cars which are 30 years old or 25 years old because they work, so they don't touch it, right? They don't upgrade it, they don't change tires, they don't go to a salon to get a new car or something like this, because the one they already have is just working fine, right? So why get better car, more economic and so on? No point doing that.
Right. Okay, I'll let you take the floor and sail us through the Java 15 and Java 16, and I'll just pop out with some questions every now and then.
Okay. Yeah, it's kind of a shame that we cannot meet each other in person. Yeah, so this stage is only virtual. Nevertheless, welcome to this short presentation about sailing Java 15 and 16. So who am I? As Dan said, my name is Piotr Przybył. I live and work in Poland, basically in this very place, and not only during the lockdown, but also during the normal times. The only thing for now, lockdown is hurting me is this terrible haircut. So you need to excuse me, but barbershops are currently locked in Poland. So yeah, I entitle myself as remote freelance software gardener. We've already discussed that, and my personal webpage is softwaregarden.dev. So if you're interested, if you need more about Java special records, then you're free to visit this page. I also work as a trainer. yeah, so even when I go on a holiday, provided there is a holiday, Java is somewhere behind me, right? So I can't get rid of it, basically speaking. And I haven't been working with Java as long as Dan is. Nevertheless, I've been with Java for quite a long, I'd say, since Java 1.3, and I even backported some code to Java 1.2. So yeah, I've been working with Java for years. So the question is, who are you? And I would really love if you guys use the chat and type us the Java version you're using at production, whether it's like pre 8, hopefully not 8, like 11, maybe 16. Let us know what you're actually using. And caveat auditores, so please be aware that everyone can make a mistake, including myself. So verify on your own. Just don't trust random people on the internet, right? Okay, so I was told that you have hosted at one of the previous events Victor Rintea, right? So if you have hosted Victor Rintea, I think you are quite used to his speed when he talks. So I'm not going to talk as fast as Victor. Nevertheless, we have to cover both of these versions because they are released so often. So let me please talk nearly as fast as Victor does, and I hope nobody will have problem with this, right? So we had two Java versions released over the last 12 months. So we had Java 15 released in September last year, and then like a month ago, in a few days, we had Java 16, and we're gonna have Java 17 coming in September this year. So the question that arises when I give such talks is, shall I migrate to Java 16 or whatever non-LTS version we have at the time, or shall I stick to the latest LTS version? And the question is, it depends, right? I think it's the best consultant question or answer to this question. And the actual thing I would say or tell you to do is, if your software runs on the latest Java version, why not? I mean, you should upgrade it just as you upgrade and fix your car and so on, because it has better features, it has faster engine, it's more economical, and so on and so on. Beside that, LTS is nothing more. It's not a technical term, it's a business term, right? So there are companies, in this case, for example, Oracle, which says every 3 years we will release a version that is supported for these 3 years, but it's just a business term. It's nothing more like that. Other companies have different policies. They, for example, support or make a de facto LTS out of every second version, and so on and so on. I think Azul is doing something like this. So I think if you can afford to upgrade, like nothing prevents you technically, maybe you should do this, okay? And of course, maybe you should skip preview features and incubator for modules from using in production, because they may still have some slight changes unless you desperately need them and you're okay to like rewrite them and recompile the code after the new version is released. But beside that, you should be upgrading to latest Java version, not to stick to 8 or 11 unless it's really necessary because of the hardcore dependencies you have. And let me stress one thing. Neither these LTS releases or preview features are so-called banana soft or monkey soft or something that's not tested, not reliable, or not serious, basically. They are serious, they tested, they're well thought. It's just for preview features. It's kind of expected that there might be some slight changes, right? And that's pretty much it. Okay, so coolest features according to myself, because I've created this list. You might have other list. I mean, you might value different things. So I think the coolest feature is this new concurrently compacting garbage collectors, ZGC and Shenandoah. We saw them in Java 15. Then there are records from Java 16 and pattern matching. Finally, we have pattern matching to start with off in Java 16. Then we have this illegal access deny in Java 16, which is kind of not maybe a feature, but something that may prevent some people or scare some people off from using Java 16. Then we have sealed classes, a second preview in Java 16. Then we have all the cool stuff from Java projects Valhalla and Panama. And then we have helpful NPEs. And let me talk about Shenandoah GC and ZGC. Okay, so they can handle heaps up to 16 terabytes. So if you have like really huge heaps, you can go for them. By the way, they also handle small heaps just as good. It's not a strict requirement to have a huge heap to switch to any of these. And they are about short stop the word pauses. I mean, there's this phase, you know, where it's like in an American movie, right? Somebody comes into a bank and shouts out, "Everybody freeze!" So we also have these freezes in Java. It's just with these two garbage collectors, they can go to sub-millisecond. I'll show you that. and they are compacting concurrently, meaning they are trying to move objects in our heaps, in our memory, to compact the memory concurrently. So they don't need to stop our application, stop the world, and they are a single generation, but that might change in the future. So they will have again, like young and Eden and so on and so on, young generation, old generation, and stuff. And they work using jitting barriers. I'm not going into details how they work. I think you'll find it out described in the wiki pages I'm about to quote. And one thing you need to remember, because they are up to short pauses and because they are working concurrently, it means they are eventually going to use more CPU. So if you're about latency, you're going to use them. If you're about throughput, like for example for batch jobs, more probably you're going to use a serial garbage collector. So these are not perfect for everything. And yeah, please be aware that if you switch for them to have to see this short stop the world pauses, then eventually you're going to pay more for your CPU. So how to use Shenandoah? You have to use this switch, use Shenandoah GC, and of course at least specify maximum heap size. Of course, you're welcome to add more parameters about memory, about Shenandoah itself, and so on and so on. I think this is the bare minimum. And Shenandoah is developed by Red Hat and is using so-called forwarding pointers. So this is the mechanics under the hood that makes it run. And there is more for you to read. I mean, the wiki page, excellent lecture by one of the main authors, Alexei Shepiliov, and so on. And now about ZGC coming from Oracle. So to use ZGC, you go for use ZGC, and again, it's wise to specify at least the maximum heap size. And then ZGC is using so-called color pointers to check if the garbage collector's face is matching the face of what the object is currently on, and so on and so on. I mean, it's kind of it's not rocket science. It's worth knowing, and there is a wiki page describing how it works, or a very nice talk by Erik Österlund, one of the main authors of ZGC, I think. And there's also getting started about the garbage collector in Java 11, and so much about slides, right? So let me show a little demo. I should have a demo for you. So yeah. By the way, the slides are online. The code is on GitHub. You'll find everything online, so you can repeat the experiment on your computer, because results differ from machine to machine. Okay, so there is a little program. It doesn't do anything. It just creates garbage. So it's pretty bad, because we should not only be about recycling. We should also reduce the amount of garbage we create. So this program is bad in this terms. It creates garbage. And when you run it, it just strays out the garbage collector. So I'm not going to run it. I've done it before because we're short on time, and I've recorded the results using, let me show it here. I've recorded the results using, as you can see, a Java Flight Recorder. So we have these recordings, and we can analyze them using Java Mission Control. So there are several runs, as you can see. And for CMS, as you can see, this garbage collections is pretty much red. I mean, even the automatic analysis says that something's terribly wrong with the garbage collection. So let's see what's wrong with them. And once we get there, you see that the longest pause was over 300 milliseconds, right? And you have all these pauses listed here. So eventually it might be even not that bad, but the longest pause, I mean, where the application froze, it didn't do nothing beside, garbage collecting, it was over 300 milliseconds. Then we go for parallel old. It's still red. Let's see how this garbage collector performed, and it's slightly better. For this very algorithm, it's slightly better. It's almost 300 milliseconds, but still, I would say pretty bad, especially if you need to take part, I don't know, with some auctions, with some beats, or respond promptly. When we go to G1, which is a default garbage collector right now, it's still bad. It's getting better, but it's still considered bad, as you can see. And the longest pause is slightly above 100 milliseconds. And then it gets somehow better, but still, not tremendous change. So it's like 100 milliseconds. And then we go for ZGC. Oh, we see no red in here. So we go for garbage collections. And there we go. 1 millisecond. Yeah, that's correct. We had over 100 milliseconds here, and we have 1 millisecond here. So we are better by 2 orders of magnitude at least, right? And see other pauses get shorter as well. And let's see how Shenandoah performed. Again, nothing red. Let's see the details, and boom, it's not even 600 microseconds. So and it's again the longest pause. In fact, it was the very first, like you know, the warm up and so on. So it's also, you also see the GCID 0. So the other pauses also get shorter. So as you can see, with these two garbage collectors, getting a sub 1 millisecond garbage collecting pause isn't actually no brainer, even if you're like stressing your memory very, very much. So this, I think, is an excellent answer to Dan's question. Why should you migrate? Well, it's basically about money. If you need to run promptly and answer promptly, so you just can go for Java 15. Of course, Java 15 is not supported now, so we can go for Java 16, and you see them in action, and you can choose them, you can tune them, even you can go for better results. I mean, these are just, you know, the default parameters. So if this doesn't convince the people who, you know, keep the money in the safe, I don't know what does. Okay, so yeah, let's go to another change, which is strongly encapsulate JDK internals by default. It's one of the JEPs. It's now a standard feature introduced in Java 16. I think you should read more about this change. I think it's pretty significant. It's JEP 396, and it actually goes back to the modules. So as we all know, modules were introduced in Java 9, and they brought warnings about this illegal access, you know. So it was probably, if you're running your application on hopefully not, hopefully that's not the case. Nevertheless, there was such a chance that if you were running your application on Java 9, you saw this illegal access detected, blah, 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 blah. Yeah. And then some people said, oh, these are just warnings, ignore them. It's just warnings, nothing important, right? Warnings. And what's worse, many people followed this advice, right? So yeah, warnings, let's ignore them. And the thing is okay, it might be a warning, but some people take warnings as seriously as compiler errors. And maybe that's the case we're going to see in the future soon, because this change introduced a new parameter, illegal access permit, which by default was set, illegal access, which by default was set to permit, and was promised to be kind of a temporary, that in the future this there will be another level and so on. By the way, there are 4: permit, warning, debug, and deny. And yeah, so this was promised to be temporary, and this caused only one of these warnings to be emitted. So now in Java 16, we have illegal access set to deny, and now this whole option is deprecated for removal. So it means that now we can go back manually from deny to, for example, the more relaxed options, because deny means that it will print you just details about the first warning about deep reflection, and then it will stop completely, right? So now it's the default, and we can still go to these easy options. Nevertheless, it's deprecated for removal. So in the future, you won't be able, most probably, I can tell why, to make it more relaxed. So what to do about this? Let's say you want to run your applications in Java 16 and you see this warning. So the best thing to do is basically to stop using set accessible true, because it means you're committing a crime against object-oriented programming, because you're using so-called deep reflection, which means you're trying to get access to private fields, private methods, and so on and so on. That's why the best thing is actually to stop using set accessible true, or use libraries that don't do that, that rely on public API and so on and so on. Then if you can't do that, then please switch to illegal access, debug, or warn, and start adding these add opens parameters or clauses. It will mean that, okay, I am aware, I personally allow this set accessible to happen, okay? I mean, for this code to open that other piece of the code, the module, and so on and so on. Another thing you can do is basically you can do nothing. You can just happily switch to illegal access permit, or even don't upgrade to Java 16, and you can keep producing legacy code, because why not? Let's let the future generation worry about this, right? Like one day they will be really forced to do something about this. Oh, we won't upgrade, so we'll just happily stick to Java, I don't know, 15 or Java 11, like, I don't know, for another 20 years or something like this. There's more about this in another talk of mine when I explain in details what's about this illegal access, these various levels, and how to add these add opens. So let's go for records now. So records are a new kind of type declaration. Records is a restricted form of a class. I'd say another type of restricted form of a class, is enum. So enums were introduced in Java 5, 5. And of course, enums are classes. You have a class, right? You have objects and so on. It's just they are restricted. We know the restrictions, how they work. So records are similar in this fashion. So we have record classes, we have record objects. It's just they differ somehow from regular classes, so to say. So they always extend Java lang record by default. I mean, this is how they are implemented. And they are named as, quote, transparent carriers for immutable data. So they are about carrying data, they are about transparency, and they are about immutability. I think both these three descriptions are really, very important. So there's an example of a record for you. So instead of a class keyword, we're just using this, type indicator record. Of course, a record can be public, can be protected, and whatnot. And then for record, we use the record's name, pretty much like in a class. And then there's something different in so-called records header. We list all these components. So this complex record has two components, both of type double, and one is real and one is for imaginary. And then a record needs to have a body, of course, always, even if it's an empty body. So this is the minimal definition of record. Oh, let me stop it. Okay. So what records have? Obviously, they have a name. You saw it previously. They also have record components, although they are not strictly required. And these records eventually become private final fields. That's why records are immutable, because you cannot replace a field when it's created. And they have generated accessors, and they have also generated full canonical constructor, and they have by default equals hashcode n2 string generated for us. What are accessors? Accessors are methods used to access the data. I mean, these fields. It's just they don't have this get, is, was, has been, or whatever prefix. They just share the name, and the name is exactly like one-to-one with the component's name, right? And of course, records have body, even if it's an empty one. What records can do, you can do in records, you can redefine constructors like the ones already defined, I mean the canonical one, or you can create a custom constructor if it's really needed. You can have your own implementation of generated methods. Sometimes it's important to do that. However, they should obey the contract behind them. We can have also extra methods, but I would say be careful about this. If the method doesn't strictly rely on the data kept inside the record, it's not a good place to put this method in. And they also can have static fields and static methods, and they can implement interfaces, and they can be generic, like collections we use. And what records can do is that they cannot extend classes, or they cannot be extended. They always implicitly extend Java lang record, but you can't do that even explicitly, and they cannot be extended. They are always final. They can have setters, like you don't have like in Scala something, for example, when you have a var field, we don't have such setters or anything like this. We don't have any extra instance fields. That's impossible. I mean, every field needs to come from these the components, and the canonical constructors can't be less visible, like private or something. So that's why you see they are transparent. And they cannot declare the native methods, or they cannot assign components in compact constructors. And basically, they cannot do anything that puts the immutability or just taking care of the state of the record, like the content, at risk. Basically, everything has to be immutable, set, and fixed, and so on. Records, my friends, are not Java beans. And this is the thing you need to remember. Like some people were saying, yeah, records are just Java beans only without setters. No, that's not the case. Records are records, Java beans are Java beans. Just you need to think about them like new, okay? Enums are not Java beans as well. And they are just final POJOs with accessors and without getters. And that's pretty much about them. And I like how, I think that was Brian Goetz named them. They're just named tuples, right? So we have tuples, for example, in Scala, we have tuples, in SQL, we have tuples, only they aren't anonymous. They have their name and they have the type, which is really important, because then you cannot mix, I don't know, apples with peaches and so on and so on. And one important thing, they are not deeply immutable. I mean, these fields are immutable, but if your field is mutable itself, then of course it can be mutated. I would say it's kind of a perhaps bad design. Nevertheless, technically it's still possible. And sometimes they require overriding equals and hashcode methods. So also if somebody tells you, oh, you never have to override equals and hash code methods, that's basically BS. Sometimes there might be a case where you really need to, despite this might be, I would say in the first place, an indicator that something went wrong when it comes to a design phase of such a record. Okay, so let me show you a record, a simple record. So this is a record. This is how we use them. I have this simple demo method, okay, main about hello records, and this is how I declare two complex numbers, and then I can multiply them and print them and whatnot. So let me run this demo. Let's make sure it's running. Apparently it is. That's really nice. And you see this is the default toString method being used, right, when it's generated. So let's visit this record class. As you can see, it's public because why not? It's record, and then I have these two parts, and then I have a body, but in this very case I had added a few methods. An add method which can add two complex numbers, subtract method, the opposite, and then there's something I can use to multiply the records. And then, of course, I can also override the toString method because this is the format I used at university. This is how we used to describe have. So we can have records without, if it's useful, but still technically possible. You can have with one field. We can have records which are generic. See, this is something that's serializable. This is something that's a number. We can have records with custom methods, but I'd say this is an example of bad design because we have a method that's not related to these pieces of data kept inside this record. Then, of course, we can have records with static members. You see there's a static field, there's a static methods. Then we can have, of course, records which have so-called mutable fields. I mean, they are deeply mutable because, of course, we can bump this counter inside. And I would say this isn't very fortunate use of a record. And then, of course, we can override toString method, and then we can override equals and hash code methods. By the way, this is one of the, we'll show that later. So sometimes you need to override these methods, still make sure they obey their contracts. And yeah, then we can also have custom accessors. For example, you need to log that, or I don't know, have a side effect, or I mean, it shouldn't be the case usually, right? Like 99% of the time. But sometimes you really have to. So then you can override this this custom accessor, or maybe you need to like create a copy of mutable collection or something like this. Then we can have this custom custom full canonical constructor. You see, so I have 4 components in here. And let's say I need to make sure that these 2 components are different, that A is different than B. So what can we do? I can, of course, create these asserts. Then I need to override these fields, and I even can print it out, right? So I call it the constructor. It's just, you know, it's outside the scope of official targets. It's listed in a non-goal section of JEPs. So officially, they're not meant about counting or counter attacking this boilerplate. But as you can see, it's a bit of ceremony. I have this list of components in the header here. Then I have this list of these parameters here. Then I have to reassign them here. It's pretty much ceremony, right? So we can get rid of this ceremony by using just compact constructor. See, I have no list of arguments whatsoever, so I don't need to reassign them. I don't need to list them here. I just, check the invariants. I just, report, okay, this is the constructor code, and that's it. That's pretty much it. So it's really easy to add just, a few invariants or checks if this record makes any sense at all. And of course, we can have custom non-canonical constructors. So see, I have 2 components, both ints, and I can still create another constructor using just string, and I then feed with length and hash code. By the way, this is one of the reasons why I can't name it a hash code, because the accessor for this component will, of course, collide with the hash code method. So we can't have components named like this. And also they can have less visibility. You see this record is package default, and this constructor can be less visible, and they can implement interfaces. For example, in this very case, comparable. So these two records are comparable, no problem about that. And also we can have this override above accessors, despite there is no accessor in a superclass, but still it's valid. Okay, so let's briefly see what records can do, because there are also some limitations, as you've seen. Yeah, what they can do is, by the way, this code is running as well, so you shouldn't caught me cheating. Yeah, again, exit code 0, and the whole output is here. I mean, accessing 12, that's all. And as you can see, they cannot extend any other class. By the way, extending Java util date or even using Java util date these days, I would say it's pretty not smart, so to say. And of course, they cannot be extended, as you can see, and they cannot have any extra super duper private fields or whatsoever. It's impossible. And they cannot anything even closely resembling setters, except when you're mutating like a mutable field, as we saw in the previous example with this bumping. And they cannot have any native methods, of course, and constructors need to have the same visibility. If I remove this, you see, it's, well, surprisingly, IDE is not coloring this, but let me try this. Okay, yeah, I made a mistake. Sorry, of course, it should be private. Like, yeah, that's the correct thing, right? So I cannot have a less visible canonical constructor, so they have to be at least as visible as the record itself. However, non-canonical constructors like custom constructors can be less visible, no problem about this. And also in compact constructors, you cannot reassign fields, right? So it's even illegal to do something like this. And of course, they also need to have exactly the same names. Like you have foo bar with capital BAR, meaning we cannot go for a constructor which has foo bar with A and R in lowercase. It's illegal as well. It's not going to work. So where are they useful? What's the like? Where are the places where I see they can be very, very nice to use and have? One of them is nesting records. So they can be nested just like static classes, but we can also have local records. And they are very handy for like stream, reduce, basically any kind of accumulator or result of any computation. So I should have another demo for this. Yeah, so when introducing people to Java 12, I had this demo about team garbage collectors, and it used to look like this. Okay, so what I'm doing here is just I have a stream of a few numbers, right? And I want to get a sum and a count, and I don't want to do that in two passes. I just want to do that in a single pass. So I can either go for reduce, or I can go for teeing collector. So I use counting collector and summing long collector. So in just one pass of this stream, I compute two things. Let me run this code because why not? Yep. Should be working. Yeah, again. Yeah, so we have the sum of 190 and a count of 20 numbers. Okay, it's just for use this count and sum as a result in order to avoid such a ugly things as arrays or something, because you have just two longs. You don't know what they have inside, right? They don't have names whatsoever. You can easily mistake them and so on. And that's why we should have classes for this, perhaps, so they have their own names and types. And as you can see, I have this single or simple Binish-like class. So it has two public fields, so I'm not even using getters. I have just a constructor, which looks like a full canonical constructor, and I have two string methods to make sure this result doesn't look so ugly. See, so this is the result of these two string methods. So many lines of code for quite a simple computation. And now instead of this bin class, which as you can see still doesn't have equals, hash code, getters, and so on, I can just go for this record. Let me rerun this code. Voila. Results are pretty much the same, right? And as you can see, this is when they are very, very nice to use. So I have this record just as a, to keep these two longs. And perhaps the most important thing, if you haven't noticed so far, is that I didn't declare it in a separate file. Heck, it's not even like a static class or whatsoever. It's just declared inside the main method. It means from now on in main method, from here till the very end of main method, I can use this record, right? So if you need just a type to do some handling of data you're calculating or using in a computation, you just declare a record and boom, you're happy to go with that. So they don't need to reside even if their own files or something like this. They can be pretty much local, meaning declared in a side method. Okay. Yeah, so records are very nice when used with other features like pattern matching with instance of and with sealed hierarchies. And in the future, we'll see pattern matching with reconstruction and so on and so on. Really, really super cool. More on records on my blog if you're interested. I mean, I've been playing quite sick with records and Lombok at the same time and whatnot. So if you're intrigued about this, please visit my page. And another cool feature, which is pattern matching for instance of some call pretty much ceremony. So we have this integer here, and despite we know and compiler knows it's an integer, now we have to go for integer here, and we have to cast it. So it's like integer, integer, integer. And we can go now from Java 16 like this. We can just, after this instance of check, we can just alias this variable, and then we have this integer used here. See, integer times 2. So we get rid of this class, this line, we get rid of the ceremony. Yeah, so I think it was Dr. Venkat Subramaniam who called it smart casting, and I very much like this name. And it's so smart, you can use it even outside like if statements, right? You can go for, see this, this if object is instance of string, and then if it is because of the circuit breaking rules and so on and so on, we can go for then, okay, check if this string is not empty. See how nice and elegant this code is right now. And of course, we all have sooner or later non-empty string methods somewhere in our projects, unless we're using like Apache Commons or Guava or something like this. Okay, so these local variables from used in pattern matching with instance of aren't implicitly final. Theoretically, you can override them, but I'm not sure if that's a good idea. They are visible in the scope they declared. I mean, they're not visible after the scope they declared, and they can shadow field names. Be careful about this, not to shoot your own feet. And they can be used, you see, in such a nice piece of code, like as I have shown, as you have seen, something like this. So we have this check in here. We don't need any explicit casting, and we can check if this string has a proper length. Or then after checking that this is a proper long, then we can check that this long is within a range we are interested in, for example. So that's possible as well. And of course, we will have more and more pattern matching in Java, especially in using records and using these the switch expressions introduced in Java 14. We will be able to deconstruct records, for example, so we can not only construct them. So, and using constructors, we'll be also able to kind of extract some data after they are matched using their classes and so on and so on. Yeah, very useful records. And now let me go quickly for helpful null pointer exceptions introduced in Java 14, and they are turned on by default in Java 15. And this is a pretty nasty code, right? But it's just a demo. Don't do that in production, of course. So we have this long, deep chain of beans or pojos or whatsoever. And when we print it, it works nicely. It's just then we pass it to someone. Somebody makes a call on this A of ours. And then when we try to check the length of this very finito string, then kaboom, we see null pointer message, right? And line 37 is this very line. And now tell me, my friends, I mean, if somebody knows an answer right now without cheating, tell me whether A or B or C or where was the null. Maybe fan was the null or E was the null. We don't know that, right? And then what we need to do, we need to go for a debug, or we need to add more checks, or we need to hit enter so each access is in separate line. Madness, basically. Now, no need to fear since Java 15. Because it says it tells us that it cannot read field F, so this field, because the field E is actually null, meaning someone in this code messed up with the objects we passed them, and now we know that E is null, so it makes our debug, our daily work much easier. Again, think money. if it doesn't speak to your stakeholders. Yeah, so there are also preview features as implementation of JEP 12. Basically, you switch them using this -- enable preview switch. And if you need more, I also cover them in one of my talks, how they impact your code and so on. And one of the preview features we see in Java 16, and I think they will be standard feature in Java 17, which is very nice. It's sealed classes. So sealed classes, because we have these access modifiers like public, private, protected, and the default one, right? And currently they're doing two things. First, they make your class visible, and then you make your class extensible, unless you are using final. And sometimes you can't use final because it's like your JPA entity or something, right? And then if you can't reduce it from being public and you can't make it final, you're pretty much stuck, because anyone can extend your class and then mess badly, right, with your library or something like this. And sealed classes are about addressing that, so prevent this bad or unintended inheritance, right? So we have this simple diagram, see, and this is our library, and this is the user land, and we want users to be able to go with this blue or bluish arrows so they can use our types, but we want to forbid these red arrows, meaning they should not be able to inherit our classes, right? So they cannot extend or implement, but they can use it as, I don't know, parameter types, return types, field types, and so on. Okay, so this is how we do that. We just say that our class or interface is sealed, and then after permits, we list the classes or interfaces which are permitted to implement or extend us, right? Or this very type. And then for sealed, again, because this is like it started the sealing in hierarchy. It means that this has to be sealed as well, and it permits a library type implementation 1 and library type implementation 2, pretty much as we see here. See, so I permit in this, I permit this, and here I permit only this, right? And if you use sealed, then all the children also need to be sealed, or can be final, or can be non-sealed, meaning I'm just going wide open again, because why not? And as you can see, I cannot go for anything like this. I cannot extend, I cannot implement this library type. However, I can use it, as you can see, for example, as method type. I can use it as field type, because why not? And this is really, really important. And together with modules, what we also saw with this illegal access, it actually allows us to have better design, cleaner design or cleaner architecture. Everyone is obsessed, I hope, at least, with clean code. Not so many people are obsessed about clean architecture. And so people think like microservices, we will go for microservices, everything will be cool, except then we create micro monoliths, right? Because somebody is inheriting our class or using our class. So to prevent using, we can go for like making these classes package private or things like that, to make sure nobody can like still create the classes in this very package. We can go for modules. So modules are about, you know, sealing in like architecture, very nice. And this final piece, like seal types, are really, really cool, because I think they, unless you play badly and, you know, use this reflection, deep reflection, and so on and so on, they will keep our architecture really, really clean. So we don't need any external tools. We just use the Java-C, Java compiler. And many people complain, especially, you know, those who come from like dynamically typed languages, that compilers are, you know, like too strict or causing us to work more. Think of it this way: you are always working in a pair with compiler. Basically, compiler is a good friend of yours. You're always pair programming with your compiler, and the compiler wants to warn you when you are doing some rubbish, right? Some stupid stuff. Okay, so there was also some stuff removed. So just for Java 14, in case you're not up to date, we have no more concurrent mark sweep. In Java 15, we also had Nashorn removed. So there's probably a separate build of Nashorn right now, as far as I know. And we also no longer have Solaris and Spark builds when it comes to Java like ports. However, since Java 16, we have 2 new builds, which are for Windows ARM for this architecture, and also for Linux Alpine, which can make our Docker images even smaller. Please note, I didn't mention text blocks, which went standard feature in Java 15. I think they are not so much interesting. Okay, so there's a code for you. You can clone these repositories. You can fetch them, download them, and play on your own, experiment on your own, because that's the best way of learning. And please, dear attendees, always and at every event, not only this very PentaBAR, but every PentaBAR, for every event you take part in, always provide your feedback to the speakers and to the organizers. I mean, in normal days, people even used to give me papers, hand papers. This is a link to a very simple anonymous poll. I don't see who you are in this poll. Just please fill this poll. And I think this is it. Dan, do we have questions? Do you have questions?
Yes, we have a couple of questions, and I will start with the latest one about the sealed classes. Razvan is asking us if won't sealed classes prevent me to create my own class based on something in the library? For example, I created a custom CRUD repository based on Spring Data CRUD repository.
I'm not sure if I got the question correctly. I'm trying to see that in, is it somewhere in chat or?
It's in the Q&A section.
Sorry, Q&A. I'm not so much of a Zoom user, sorry. Yeah, okay. Let me just, because I'd like to make sure I am answering the right question, okay? Oh. Yeah, I mean, this is the very purpose of the sealed classes, to make sure you are not using your class or interface so it cannot extend or you cannot implement something if the author of the sealed class or interface didn't allow you, meaning it wasn't listed here in this permits, which means that sealed classes work okay if they are in the same package or if they're in the same module, depending if you're using modules in your application or not. That's why it was for the authors of the libraries, I would say, or frameworks, to make sure that sometimes they need to seal something, because instead of, for example, composing or using properly, people went just for inheritance. And inheritance, my friends, isn't bad itself. It's just badly used sometimes. And this sealed is about this. It's about making sure that people cannot implement or extend your class/interface when you don't wish to, basically, when you know it's a bad idea, right? So just as we make sometimes final but final is kind of like a atomic option. You either go final or not, right? Then even you cannot extend your own class. Where sealed is about being picky. You can, you can't, right? And yeah, so, but I don't think like everyone will seal their classes. I mean, people, the authors or libraries or maintainers will seal classes whenever they will find out this is appropriate, right? It's not by default of anything like this. It's an extra thing. It's not colored properly. It's not red here because this Java plugin doesn't recognize it as a Java keyword. But I should have like sealed. Sorry. We should have a demo for that as well. Let me just, maybe we won't go through this demo, but at least let me show you where it is. And it should be here in, sorry. Yeah, we have sealed module and sealed unnamed. If you need to go for more, and here should be sealing. Whoa, where did it go? Yeah, here. See, so this is exactly the code you saw in slides, right? So I cannot go for this or this, and the message is not allowed in the sealed hierarchy, basically. Meaning we cannot also, that's why there are all these two modules, sealed unnamed and sealed module, because there are different rules when it comes to visibility. Basically, if you are not using modules, all the sealed members or the members of the sealed hierarchy need to be in the same package. Whereas when you're using a module, like releasing a module, they need to be in the same module, but can be in different packages, right? Which, by the way, might be a good move as well. Any more questions?
Yes, I would go back to the garbage collector improvements. I think for less technical guys, this is one of the biggest benefits of the newer versions. And my curiosity is, can we benefit from this improvement just by changing the Java distribution in production, or do we need to change the code base, or recompile?
No, there is no such need. I mean, as far as I know, there are some backports of, at least there were some backports of Shenandoah to Java 11. It's just, or even to Java 8, to some versions of Java 8 from some vendors. It's just they weren't as powerful and as modern as these, which we see in Java 16, because they received, ZGC got an improvement in Java 16 even. Now it's like, has poses which are independent of the number of thread roots, basically. And you don't need to recompile your code or rewrite your code to be able to use this like Shenandoah GC or use the GC. It's one thing, you need to be able to migrate or run in the first place, right? So if you're, for example, using or having a code which doesn't run on Java 9, on Java 11, for example, because might be, let's say you're casting the value from string as a character, not as bytes, then it won't work, of course. But provided it's working, there is no need to recompile. You can just use the same jars, and that's pretty much it.
Okay, another question from Evgeny related to garbage collecting. Are there any use case scenarios when older garbage collectors might become more performant than the latest ZGC and Shenandoah?
Yeah, there are cases. I mean, even for G1, there are cases because G1 received and keeps receiving improvements. So if you have really hard times with performance, with long pauses, then even if you don't want to use ZGC, you should go for latest builds because they are basically better and better. And any specific algorithms, I can't tell. I mean, there is here is an example of a nasty algorithm, and of course, when it comes to performance, then most probably you're going to go after Java Flight Recorder or async profiler. You're gonna go for these flame graphs and analyze, because maybe you need to change your data structure and so on. So it might be not related at some point to garbage collectors. As far as I can tell, they are not infected or for any kind of specific kind of an algorithm, whether they're good or not. It's rather the use, right? As I said, these are good for online processing, basically, when you want to make sure your application doesn't freeze for, like, for example, for 50 milliseconds, so people won't have such a long requests by bad luck, basically. And when you are about offline processing, like batch processing, for example, so heavy computation, most probably you're not gonna use them. You're gonna stick to G1 or even like parallel garbage collector. Okay,
one question from Georgiana. From all the new features that came with Java 15 and Java 16, can you make a top 3 for each version of the most useful ones? I think your selection today was your top 3 already.
So yeah, but it's my, please remember, it's my selection, right? It's like your selection can be different. Like some people, if you need to create a lot of integration tests using SQL or JSON, for example, you will go for text blocks, which are missing here, right? So it really depends on the person who's using Java, especially when it comes to language features.
Right. A question from Marius. What OpenJDK distribution do you recommend for Java 16?
When it comes to OpenJDK, there's only one. There's OpenJDK, right? And then there are the other distributions. And actually, it more comes to this paid versus unpaid, because paid distributions can have better diagnostics, can have even custom garbage collectors and stuff. So it really, I think if you are about asking such a question, we are at this not like writing software, but about running the software, and it's like, I guess then there should be some specialists, because I don't want to give any precise answer to this question, because it's like it's always depends. I would say it's always depends. For development, I think unless in like really rare case, most probably you wanna go with any of them. Any of them should be as good. However, sometimes, for example, you might not see Shenandoah. So sometimes you want to go for example, for Adopt OpenJDK, not just OpenJDK. And by the way, if you're not sure which one you should use, there is a very nice thing. It's called Sdk Manager. So you can go for SD once installed. It works very nice on Linux and on Macs. It works also on Windows, only it's a bit more difficult to install. Then we can go for SDK list Java. And as you can see, I have all these versions listed and available from OpenJDK and also from JavaNet. So as you can see in this version, I'm using Java 16. However, I have these others installed, and there are also other options. So if you really need to switch between them, it's really easy. You can go, as you can see, let's go for a Java version. And as you can see, I'm using 16 in this very shell, and in the new shell, I'm gonna use, but my default one should be 11, I believe. Version, yeah, see, it's Java 11, and still I can switch to another version. Let's say I have this one installed. So if I want to go for Java 8 in this shell, sure, why not? Use Java, and then boom. Oh, binaries are not available. I must have messed something with my setup. So let's go for 15. Although it's deprecated, SDK use Java 15.02. Yeah, so Java version. And now you see I'm still, well, it's still not working. It's not available. Possible causes, invalid version. Anyway, I'm really surprised. No, it has to work. Sorry, it has to work. Or I messed something with my installation. I was updating a lot of stuff like 2 days ago. This one, again, it's not available. I messed something, but a general SDK Manager allows you to switch versions. As you can see, I have here 11. I had here 16, and I don't know why the others are not accessible despite they should be. But if you are worried about whether I should use this and this, you can easily install both or many of them and switch between them in various tabs. And you can also have a list of them in your IDE. I should have that as well. Let's go for settings. See here in settings, where is the settings view? Yeah, sorry, not this settings. Settings of the project. I can just show you that here. Yeah, let's go for the settings. And language level, but I'm not about language level. I'm about project C, and I can select any of these, right? Any of these versions, and run my project or compile my code against one of these versions or JDKs from various vendors. As you can see, I have Java from OpenJDK here, and this one is from Adopt OpenJDK, and I have even something from Azul and whatnot. So it's really easy with SDK Manager or even IntelliJ itself these days, because we can do that in IntelliJ as well. Only then using Maven gets more complicated, but it's still possible.
Okay, I still have several questions for you. One still from Marius about serverless contexts. Is there any improvement in the latest Java versions, in Java 15, Java 16, to lower cold starts in serverless contexts? Do you recommend?
I haven't checked that. I can't answer this question. So I won't speculate. Okay. I think it should depend also how this serverless is set up, because contrary to the name, this serverless probably is using a server somehow down below, and I don't know what JVM is installed there, how it's configured, and so on. So it's really one of these it depends questions.
Okay. We are talking about the possibility to migrate and the compatibility with external dependency libraries and so on. We have a question from Rami. He's writing a plugin for an OSGI application, but he's still restricted to write the code in Java 8. When do you think we'll start migrating to newer LTS Java versions?
I don't know. I can't tell. I know there are people suffering from being like contained to Java 8 in quite a few, I would say, libraries. It's just then because actually there might be this question, or soon we might see people or like Java divided into not just two but more like branches, because previously we saw Java 6 because of the Android, especially for this mobile market that might have been a problem, and we saw like the backend guys going for 7 and 8, right? And now we see the backend also divided, like we can go for 8 and nothing more recent, and the others we can go for the recent version as well. And I don't know, I can't tell. I mean, I'm like, you should contact the maintainers or your vendor. When do you think they will go for it? For some companies, it's really problematic because they cannot find a reliable replacement for the API they used in Java 8. And then we come back to Project Panama, but because in Project Panama we have very nice access to off-heap memory, because that's usually the case. And then when this gets mature, probably there will be, or maybe not probably, but then will be a chance for such people, for such libraries to do this huge jump, like, I don't know, across 10 versions of Java or something like this. And then it comes to the quirks with these modules and so on. So basically, I mean, I'm not going to point any fingers right now, and I trust you people are confident enough with using Google or another search engine. It's just there were some parties strongly opposing against release of Java 9 because of these modules, because of SunMist Unsafe, and so on, because this broke their business model, basically. Because despite the name SunMist Unsafe, and despite being officially told that whatever is in Java packages and packages below, and or Java X package and packages below is the official API. Anything else is unofficial API, which should not be used, and so on. They decided to use it, and so they took that risk, and now we might be in a way victims of this risk, right? So apparently their solutions don't work with anything modern, because they use some quirks, some hacks, whatever we call it. And now we are where we are. And I'm sorry for all these poor souls who are stuck to Java 8 despite wanting to go to something new. Well, if you can't change that, maybe you can at least influence someone, or then maybe you can go for microservices. So some parts are using, I don't know, Java 11, Java 16, and some other, when really needed, are still using Java 8. So there might be some options, right?
There are also some lucky guys using Java 11 or Java 16, as we saw in the answers our audience.
Yeah, that's why I wanted to have this
initial
answer.
question. I have a more philosophical question, I think, from Cosmin, but I think it's a good question to end our meeting today. What will Java look in the future for? Is it going to lose more space on the backend in favor of JavaScript, Go, Rust, any other fashionable languages? More specifically, if you would start a project from scratch with a microservices architecture, would you use Java by conviction or by passion?
Oh, that's a tough question. That's a very tough question, Dan. And before I answer it, let me know that I am not representing in any official way any of the involved parties. So these are just my views. And also, before I answer it, let me just go back one step, okay? Because many people are excited about any other languages or technologies and so on. It's just, please be aware that Java recently celebrated its 25th anniversary. I mean, this is a technology and an ecosystem and language which is quarter of century old. Sometimes it's older than the developers, right? So it's not that they can, I mean, the Java team or the Java architects, they can toss any feature or they can break any backward compatibility. I mean, there are some backward compatibilities broken intentionally, and they like say, okay, it's not gonna work anymore. Like, for example, Nashorn or like applets you mentioned sometime earlier. But they are not just deprecated everything. Like, for example, in Scala, it was kind of obvious that there might be no source compatibility between minor versions, right? Like, people took it for granted. It was not the premise from Java. From Java, it was always like it's going to be run in the future, and only the Java 9 broke this contract, meaning that sometimes your at least officially, right, your program may not run in this approach. And when you take a look at this, then, as I say, there are at least few Javas we are going to see in the future, I would say. So apart from this Java 6, unless there's going to be some kind of a migration, perhaps, or maybe not, because these folks are using quite successfully Kotlin, there might be this, we are going to stack with Java 8, and we are going to for this new Java version. And I'm not going to also like say who's better or who's unlucky and so on and so on. It's just life. Basically, it's just life. And then let's take a look at the older technologies like COBOL. Whether we like it or not, there are still COBOL mainframes, right? I mean, there's a lot of things still being computed in COBOL and by COBOL. So, I mean, are we going to blame someone for not migrating to this? I don't think so. And if Java is going to be used by microservices, to answer that specifically, I'm really not so much afraid about position of Java, and I would be maybe more afraid of position of microservices, because maybe there is like, I think there was a time, certainly there was a time like a few years ago where microservices were overhyped, right? And instead of going for proper modular architecture first, people went for microservices, but they weren't modular, so we ended up with modular monolith. And these are terrible to maintain, to develop further, not to mention like versioning and so on and so on and so on. I mean, you people, just as I do, you know what I'm talking about this pain. Then some people discover that actually TCP calls using JSON are much slower than inter-process calls or even in-process calls on a single CPU and so on. So sometimes, you know, it's not a simple check between vertical and horizontal scaling. So this is a bigger question, and how we all see our future using that, I don't know. Well, there was a time, especially around Java 7, when I was kind of thinking that Java is going to be kind of a like assembly language, and we're all going to use to switch. We're going to go to switch for Kotlin or Scala, right? And JVM will be just an excellent runtime or running platform. But it turned out with Java 8 and then subsequent releases that despite its age, Java is still moving forward at extreme pace with extreme velocity, I would say, for such an old technology and language. So I'm not worried anymore about my like position or business title, my CV having Java on top, really.
My perception, and I think you share it, is that Java is still sexy, and we should be proud of using it and knowing it. It improves with every version. Thank you, Piotr. I remember you told me about Project Loom and other future reference projects, and you're quite excited about what's following next with virtual threads and even a better use of memory and so on. So there is still a solid future ahead of us. We just need to keep up with the progress Java is making. Thank you very much for joining our PentaBAR. you will find the recording of our talk on the usual social networks of Pentalog, but also on our website. Maybe we will just repost the link for our video library to all the previous PentaBARs. I suggest we stop here. Please don't forget about our feedback. We learn a lot from your feedbacks and Piotr as well.
Yes.
And we also have some challenge ongoing for Java developers on our skillvalue.com websites, and I think it's nice to check your skills against this kind of challenges. We'll meet with Mihai and our future guests next week. Have a nice day, everyone, and join us next week and further on. Thank you, Piotr. Bye-bye.
Thank you very much. Bye-bye.
Papa, I learned Polish.
Okay, yeah, I see.